Good morning, students. I welcome you all to this session, and today we are going to discuss a very important and popular algorithm called as merge sort, which is a very good example of divide and conquer strategy. The merge sort is a sorting algorithm that uses divide and conquer strategy. In this method, division is dynamically carried out. Merge sort on its input array of n element consists of three steps: divide, conquer, and combine. Now, the divide process divides the array into n by 2 elements each every step, and conquer will then sort these sub arrays. And finally, the combine process merges these sub arrays into a sorted group of an array. Now, here is an example of an array consisting of 8 elements. The elements that I've considered is 8, 3, 2, 9, 7, 1, 5, 4. I hope that you can see this PDF file on your screen. And these are the 8 elements in an array. I consider the array as A and the size of my array as 8. So 8 elements are to be sorted in a non-descending order. So how does this algorithm work? Now, having considered an array of 8 elements, the function merge sort begins by splitting this array A into sub-arrays, each of size 4 and 4, so that it can just store 4 elements each. Now, if we just trace this, I've given a diagram here. If we just trace this entire array is split into 2 sub-arrays of size 4, 4 each. The first sub-array contains 8, 3, 2, 9 as the elements. The second sub-array contains 7, 1, 5, 4, 4 elements in its second sub-array. Now, this is done in the first iteration. Further, these 2 sub-arrays are divided into 2 more sub-arrays each. So now in the next level we can see that there are 4 sub-arrays, each consisting of 2 elements each. Further, we try to divide this into further sub-arrays. So you can see in the next level that we have each array consisting of single elements in it, single element in it. Now here we end the process of splitting, that is dividing the arrays. From now on, we are going to merge these elements, and while merging these elements that are part of the subarray, we perform the sorting of these elements. So in the next level you can see that 3 and 8 is sorted and merged into a single array. So this array contains 3 and 8 as the elements. Similarly, 2 and 9 is combined. While combining or while merging, 2 and 9 is sorted. 1 and 7 is sorted. 5, 4 is also sorted. The same technique is applied in the next stage. Here we'll find that 3, 8, 2, 9, two sub arrays are clubbed and a single array is generated out of it, and the elements are sorted and it contains 2, 3, 8, 9. Similarly, we have another subarray with 1, 4, 5, 7. All elements are sorted, we need to observe here. So in the next stage, we try to again merge these two subarrays, and finally we obtain a single array with all the elements sorted in it. So the strategy is dividing the arrays in such a way that we are left with only one element, and then we go on merging these or combining these arrays, and while combining we try to sort it, and at the end we'll find a single array which contains the elements that is totally sorted. So this can be performed for sorting the elements in ascending or descending order. Now in the right side of the page we see an algorithm called merge sort, and this is the algorithm, or this is the recursive function that is key in dividing and merging these elements. We pass two parameters, L and H. L represents low, H represents the high, which means that if my index starts from 1 for this array A, L represents 1, and the highest index here is 8, and 8 is stored in H. So we pass the initial index and the final index, 1 and 8, while calling merge sort. I have a conditional statement within this merge sort algorithm. Here I'm checking whether low is lesser than high, which means that I go on dividing this array into smaller array until I'm left with only one element. If I'm left with one element in an array, L and H will be same. So this condition evaluates to false when I have only one element in the array. Okay. Now within this if conditional statement, the first step that I perform is to find out the mid element. Now let's get back to this tree structure, the diagram given here. I have 8 elements. When I try to split this array into smaller subarrays, the index is 1 to 4 for this array, 1 to 8, and when I add 1 plus 8 divided by 2 will give me 4. So now I'm going to split this array into two subarrays. The first subarray will contain the elements from index 1 to 4, that is from low to mid. And the second subarray will contain elements from mid plus 1 to high, that is from 5 to 8. That is what I am doing here in my function call of the recursive call of the same function. The parameter that I am passing is L, mid. Obviously, in the next function call, I'll be passing mid plus 1, h. So this is 5, 8 first time. So I'm now trying to divide the array into two sub-arrays with the help of these function calls. Once the arrays are all divided into smaller arrays with single elements each, I try to merge those sub-arrays. So while merging, I'm going to call a function called as merge, which we are going to discuss later. So the parameter that I'm passing is low, mid, and high. Okay. So this dividing goes on and until single elements are present in my array, and once it reaches that single element in an array, merge will take over. Merge goes on merging these arrays by sorting it. This is the main function that we are going to call, or this is the function that we are going to call from the main function in the program. So let's see the merge sort call function in detail, especially with respect to the parameters that we pass. First time when we call this function, I said that the parameters that we pass would be the index value of the array. 1 represents the lower index, 8 represents the higher index. Since we have 8 elements, the first index value would be 1, the last index value would be 8. And further, if you just see the merge sort function, we are going to call merge sort many a times until we are left with only one element in the array. That is what I said. So first time when it is called, we are passing L comma mid. So 1 comma 4 is what we are going to pass here. Similarly, low becomes your new value of L is 1, high is 4. Again, I'll find out the mid value. When I find the mid value, 1 plus 4 by 2 will give me 2. So 1 to 2, 3 to 4 would be the index values of the subarrays. So it goes on dividing. So here I've shown in the leaf nodes, the low and high values are same. Obviously, the condition within the merge sort will fail if we encounter these values. So this tree representation is an idea of how the arrays are split into smaller subarrays. Now let's try to investigate the working of merge sort function. Merge function. So merge function, if you want to understand, we'll take a small example where we're going to consider the array containing 8 elements. Here on your screen you will find that I have 8 elements: 2, 3, 8, 9, 1, 4, 5, 7. So these are all elements that are stored in array A. That is my assumption now. Now when I split this array into 2, the first element index would be stored in H, which means that I'll be storing L into H. Okay, so it will be 1. The last element of the first subarray, its index, is obviously stored in mid. We know that. The next element after the mid, the index value of that element is stored in in J, and the last element's index is stored in high. Right? So when we are trying to split the array into 2, these are the index values that are stored in these variables: H, mid, J, high. Now if you investigate this merge function, we are passing 3 parameters: low, mid, high. Right? We are passing only 3 parameters: low, mid, high. Low, low, I'm passing low to H. I'm storing the low value into H. So obviously H will be pointing to the first element of my initial index of my first subarray. Similarly, low is pushed into I. We will just try to understand why I is required in our program a bit later. And J is equal to mid plus 1. So J is equal to mid plus 1. So mid is pointing to 9, j we want it to be pointing to the next element after 9. So obviously I'll push mid plus 1 into j. Okay, so the idea here is I have a single array which I call it as A, but I'm going to logically split this into smaller subarrays, but both are part of A. We need to remember that. When I say logically splitting it, I have defined the boundary of each array. What is the boundary? The boundary starts from H to mid, and then the second subarray starts from J and ends at high, even though all these elements are part of a single array A. Now let's investigate this merge function. I have three conditions that I'm going to check in this function. Just to make things simpler, understanding simpler, I've named it as case 1, case 2, case 3. Let's go back to the example once again. Now when these elements are present in the array and I'm using variables to point the indexes for these elements like this: h pointing to 2, mid pointing to 9, j pointing to 1, high pointing to 7. Now I'm going to perform merging of these elements into a single array. When I start merging, the other important thing that we need to observe here is that the elements are sorted in my subarray. It is sorted. And now I'll perform merging. When I perform merging, I will be trying to compare A of H with A of J. Now, whichever element among these two is lesser, I'm going to insert that into my final array. So in this case, E of J is lesser than H, is lesser than E of H. So the first element that I'm going to insert would be 1. When I insert this 1 into the final array, after inserting, I'm going to increment j by 1 position. So obviously after this iteration, j would be pointing to 4. Okay. What about this case 1? See, if you have few elements, one or more elements in array, in the first array and in the second array, then we are going to compare the elements, and whichever is lesser we are going to insert that into our final array, right? Now this condition is basically for that. If h is lesser than equal to mid and j lesser than equal to high, so h should be lesser than mid, which means that I have one or more elements in the first subarray. Similarly, if j is lesser than or equal to high, then I have one or more elements in the second subarray, so that I can compare these elements and try to merge along with sorting those elements. So this condition is basically for that. So when this condition evaluates, we know that there are elements in both subarrays. Now within this while loop, I need to find out which element in these two subarrays are lesser, and only that element has to be inserted, right? So let me assume that this is the first subarray, this is the second subarray. So I'm going to compare E of H with E of J. Now A of H here is 2, E of J here is 1. Which one is lesser? here E of j is lesser, so I need to copy that into my new array, right? So I'm comparing E of h, is it lesser than E of j? Now in this example, E of h is not lesser than E of j. In that case, this condition fails. I am now inserting E of j into E of b. So let me assume that I have another array B where I am trying to insert 2 into my new array. Now when I insert 2, sorry, not 2, it has to be 1, right? So E of j is inserted into B of I. So I is a pointer that is pointing to the next element that I need to insert into my new array, which is called B here. Okay, so E of j has to be inserted. So A of j is inserted into B of I. I is initialized to low initially, so it will be B of 1 or 0 depending on what is that I'm going to pass here. So here we'll assume that it is 1. So B of 1 is equal to E of j. So I'm going to insert 1 into B of 1. Now after inserting, what should I do? I have to increment j. I have incremented j. So I come out of this if conditional statement, I increment I. So I is a pointer that is pointing to the elements that I am inserting in B. It's a temporary array. So that should also be incremented. But what if 1 was here and 2 was in the second sub array? Then I don't insert E of j, rather I insert E of h, right? So this condition would have evaluated to true. I would have inserted E of h into E of B of I, and h pointer would have been incremented. So this is done in case 1. Okay. Now let's assume that the elements are in this form. Elements are stored in this form in A. 1, 2, 3, 4 in the first subarray, 5, 7, 8, 9 in the second subarray. And we are trying to execute. The compiler is trying to check this condition. Obviously, this condition will fail. Case 1 is not applied here because h is not less than equal to mid. See here, I have already inserted these elements 1, 2, 3, 4 in B, and when I insert all these elements, h goes on incrementing one by one, and then it has gone past mid. So h is pointing to the element 5 here. Obviously, h is greater than mid now. So this condition fails. Case 1 fails, right? You move on to the next condition here. It checks h greater than mid. Yes, h is greater than mid now. What does it mean for us? The elements in the first array are completely inserted into B. We are left with the second sub array, and obviously the elements in the second sub array are sorted. So we need not compare it, we can just insert these elements into B. That is what I have done here. So I have a condition h greater than mid, yes. For k equal to j, k less than equal to high, k plus plus. What is that I am trying to do here? I am pushing this j into I, which means that I will now start inserting these elements starting from 5, 7, 8, 9 into B. That is what I do. So B of I is equal to E of k. I go on inserting. So I go on inserting until I encounter the last element, and the last element is pointed by the variable high. So I stop there. See the condition if k less than equal to. Now if this is not the case, if it fails, what does it mean? Say if you have the element stored in this way 5, 7, 8, 9. So in the first iteration you would have inserted 1, 2, 3, 4. There are no elements left in my second subarray. So if there are no elements left in my second subarray, J would have surpassed high. So obviously, J will be greater than high. So this condition will evaluate to true. J is greater than high. You need not even give this condition. You can just have else. That is sufficient. So what is that I do? I go on inserting these elements, the elements in the first subarray into B. So I start the iteration from H and end at mid. So starting from H and at mid, I go on inserting elements into B of J. Now all my elements at the end of this iteration is stored in B. I have to push it back into A, right? So I need a for loop. So it starts from H to high. I copy back all my elements that is in B into A, and then I return from this function. So I hope that you have understood the working of merge sort and merge function. So now let us see the demo of the merge sort program. So as we just discussed, we have two functions. One was supposed to be merge sort, the other one we called it as merge. Now here, since I'm using an online IDE where I can directly type the Java program, compile it and run online. So instead of naming the function merge sort, I've named it main because automatically this online IDE assumes that the name of the program to be main, uppercase M, and since the name starts with main, the class name would also be main. So the constructor that I have given is also main here. So instead of merge sort, I'm using the main as the class function in the constructor here. Okay, as usual, as we discussed in the algorithm, we have two main functions. So one, um, the merge sort function, the other one is the merge function. So merge sort is this function. It's a recursive function where we are going to check whether low is lesser than high. Now we will discuss comparison later. The other statements are the exact replica of what we did in the algorithm. Find out the mid value by finding the average index of low and high. Then calling merge sort twice. First time uh, passing parameters, two parameters as low and high. When you call the function second time, we are passing parameters as, as middle plus 1 and high. So the idea here is to divide the array into subarrays, and then once we divide the array into smaller arrays where you have only one element left in each of these arrays, we start combining it, and during combining these arrays we are applying the sorting technique here. So this is done in merge function where we are passing three parameters: low, mid and high. Okay, let us see uh, what is given in merge function. So merge function takes three parameters: low, mid and high. I've done initialization of variables here. Basically these variables are meant to point the values in the array. They behave as index values. So as usual, I've started with the first case here, trying to basically check whether h is less than mid, or here I've used it as I is less than or equal to mid, and j less than equal to I. So we are basically trying to check, are there elements subarrays in both the subarrays, so that I can compare the elements of these subarrays, and whichever is a lesser element compared to the other element from the subarray, I'm going to insert it into my new array. That is what I'm going to do here. So within this while loop, I need to compare, I need to do two comparisons. We just saw that in the algorithm. And based on whichever value that is lesser, we are going to insert that value or copy that value into the new array. Now these two conditions are case 2 and case 3, where there will be no elements left in one array. This case 2 is when I don't have elements in the second subarray. Case 4 evaluates to true when I have no elements left in my first subarray. I'm going to copy that into the new array. And the last part of the function here, as I said, we are going to copy back the values that are sorted into the original array, so that we can further apply the merge for the remaining elements in the array. Now, in most of the in these, um, I think in this function, whether in merge sort or merge functions, we are using a statement called as comparison, and then we are incrementing it by 1. Why are we doing it? It was not part of the algorithm. Now the idea of developing this program and running it, compiling it and running, is not just to see the way in which the algorithm works, but we need to also do the analysis of this algorithm. When we talk about analysis, we have two types of analysis. One is the theoretical analysis, the other one is the practical analysis. Theoretical analysis, we do it using asymptotic notations, and we know that merge sort, for merge sort, the best, worst, and average cases for all three, the time complexity is big theta of n log n. Now, what about the practical analysis? Now, we can actually do the practical analysis of a program or an algorithm using two methods. One is to make sure that we calculate the time. We note down the time before the function starts executing, and after the execution of the function or the algorithm, we again note down the time. So the difference between these two times will give you the total time consumed by that algorithm for execution on a particular set of inputs. Now, unfortunately, this may not prove to be efficient always, because your operating system internally runs several processes. We all know that there are foreground processes, background processes. So we may not know how many processes are scheduled at that particular point of time when your program is actually running. It may vary. So your time calculations may be wrong. So to overcome this problem, we introduce a counter in the code, so that every time if we expect that the condition evaluates and the control gets inside a for loop, looping construct or within a conditional statement, we go on incrementing that count just to give an idea of how many times those basic blocks in the program is getting executed. You count the overall number of times, and that would give you a rough idea of how many steps did your program take to complete executing the entire algorithm. So based on this count, we are going to judge for various inputs what would be the number of steps that your algorithm is going to take to perform a particular task. Um, so here we can see that we have adapted both the techniques. One is to note the time here before we call the function. So start would give you the time before the function is called. Again, end would give you the time when the function completes its execution. So the difference of these two here, difference of these two will give you the time consumed by the program to execute this function for the input n. And we are also trying to print the comparison statement, comparison value. Let's run the program. So it will ask for the input. So let's give the input. So let me start off with 1000, and it is asking for the option whether it is for the best case, average case, and worst case. Let me go for the best case. So the best case, the time taken is 1451948 nanoseconds, whereas the number of comparisons, the counter variable basically gives me the count of number of times the statements are executed, 31,039. Let me execute it once again for a higher input. So last time the input was 1000. Now let me increase it to 2000. Again, the best case. Best case. Obviously, the time taken is increased. Number of comparison is also increased. Okay. So the objective of doing the analysis is to find out how efficient this algorithm is in sorting the elements. So to thoroughly analyze this algorithm, we need to generate a table with three different values. For the best case, what would be the timing? For the worst case, and for the average case, what would be the timing consumed by this algorithm for various inputs. Start from 1000, then increase it to 2000, 4000, 8000, and so on. So we need to at least have 5 points to represent a single curve. When I'm talking about the curve, you have three curves drawn in this graph. One curve representing the best case, the other curve representing the average case, the last curve representing the worst case scenarios. So the graph basically gives us an idea of how the algorithm is going to perform with respect to these three cases. The graph, when we draw, we will draw the graph input versus time, and that would give us the analysis of Mozart algorithm. So this completes the understanding of the Mozart algorithm. Next class we'll take up quicksort. Thank you.